This video has been produced to showcase and demonstrate 4Sight, a brand new innovation for automatic inline print inspection. This product is a collaboration between SICK and Auto-Coding Systems. Conventional OCR and even deep learning technologies regularly struggle to reliably inspect everyday, normal inline printed codes. In addition to their technology weaknesses, these methods require an investment in specialist vision skills to set up, adjust and maintain the inspection application so that it can consistently work reliably. 4Sight is an automatic solution that requires minimum involvement from the user and certainly does not require specialist vision knowledge or skills to operate. Unfortunately, with inline code printing, there are a few fundamentals that influence and challenge any inspection solution. Firstly, customers have different requirements for their coding formats and message layouts, so any solution must be able to cope effortlessly with these changes. These modifications to the message occur at the printer. Secondly, inline code printing is very often involved with printing variable information, such as expiry dates for products, traceability and identification data, unique numbers, and, of course, real-time date and time information. Lastly, and perhaps most significant of all, inline code printing suffers from a degree of natural variation. This is when small changes in one or more of the code printing variables causes a real change to the consistency and quality of the print, and also its actual location on the pack. These changes could be connected to the ink, ribbon or printhead, the surface of the substrate, the triggering of the printer, vibration, ambient light and so forth. These changes result in a different print that may or may not be acceptable. An inspection system may struggle to cope with these changes, and when that happens, the logic of the system believes the code to be of poor or bad quality and rejects the pack or stops the line. This can result in unnecessary waste and unnecessary line stops, often referred to as nuisance stops. The concepts of wizards has been used extensively in 4Sight to automate the sequence of steps required at each stage. By following the wizard's on-screen instructions, the software automatically completes a key section of the inspection application. We start with camera calibration. A simple calibration card has been created which is placed on the pack surface where we want to inspect the code. The aiming laser is turned on and directed at the crosshairs mark. Simple manual adjustments are then made in turn to exposure and focus. The on-screen traffic light system lets you know when you have it just perfect. The card is then removed and we're ready to set up our inspection. The onboard menus allow for the size of the field of view to be selected for each specific inspection, so we can ask the camera to look only at a specified area. This helps to optimize the speed of image processing. We can select from a range and step down in image size from full frame through to other well-known resolutions, and can also select a custom field of view if preferred. There are a number of easy navigation tools to adjust the field of view, or use the cursor tool to drag, expand or reduce the field of view on the screen directly. Each inspection has its own collection of individual settings, which the 4Sight method creates automatically using the Configuration Creation wizard. Each configuration covers a unique, comprehensive combination of parameters and settings from a sequence of inspection tools. Within the wizard, the user first selects the type of inspection and the number of cameras involved. In this demonstration, we're focused on print inspection. 4Sight can handle either 4 separate cameras or 4 individual inspections on a single camera. The wizard prompts the user to accept the self-determined settings or make adjustments. For example, if we know we're always going to inspect for our code in a certain area of the packaging, then we can trim back the region of interest using the sliders. Again, select and drag cursor tools and fine-tune adjustment buttons are available. Within the on-screen user panel, there is documented help that provides context-relevant information for the current setup stage. Next is a unique feature of 4Sight called Inspection Depth. This allows the user to specify the level of inspection required. The inspection works first by looking for what we call character candidates. This is useful when we are most interested in the presence only of the complete message. Next comes good character candidates. These are character candidates that have gone on to pass additional quality inspection routines that mean we now can classify them as good. Good characters are visualized by individual green bounding boxes around each character. Lastly, we can take the inspection depth to print box. This is where we add further qualitative inspection around the dimensions of the characters and their overall union, hence the term print box. On the screen, this is shown as a purple rectangle. This also now allows for location tolerance inspection of the overall message to be included. If the message is printed outside of its intended location, we can score this code as either poor or bad. The tolerances for acceptable code quality are automatically set up by the wizard, but can also be adjusted using the on-screen sliders and setting values. Once we have created a configuration, we can save it with a suitable name for future use. If we are using the 4Sight product in printer-led mode, then we can match the names of messages in the printer to save configurations on the camera. When the printer changes message, the 4Sight system changes to the corresponding required configuration. This means the operator does not need to return to the camera to adjust its settings for the new message. A strength of the product is its ability to determine how strict the quality inspection will be at each stage of the selected inspection depth. In the results interface, the user can accept the default inspection thresholds for good and bad reads, but the application is far more powerful. At each inspection depth, the minimum and maximum permitted score can be set to trigger the threshold for each classification of inspection result, that is good, poor or bad. This means that fine-tuning and a real granular feel can be applied to the inspection result. This contrasts sharply with other inspection methods, where frequently the only way to get acceptable codes to pass the inspection is to make it easier to pass. This risks genuinely bad codes being missed and defeats the whole purpose of code inspection. A popular level for 4Sight's inspection depth is print box, where we are inspecting both individual characters as well as their overall connected union as a whole message. The 4Sight tools allow for sensible human-readable tolerances to be accepted as good reads. This prevents unnecessary rejection of printed packs with codes that are less than perfect but totally acceptable. This is a critical aspect of any code inspection application. To close, we would like to emphasize that 4Sight can work with all printer brands and coding technologies. In printer-led mode, an auto-coding device driver is required, which can be developed by our own software development team within a couple of weeks. The product is available globally through SICK, and here in the US, it is led by the specialist Vision and Software Solutions team, with support locally from Auto Coding Systems LLC.